All right, this is Mr. Wyrick. I just found out I'm going to be out tomorrow. Need to go take my daughter to the doctor. So I'm just going to go through these set of notes with you real quick to kind of help everything out. So I'm starting out here on slide 13. It says day 3. It says go over the work from yesterday. What is the distance between the stars? We have to roll back quite some ways to look at it with something like this. So we can see what's going on here. I'm going to go ahead and just use this one. Here's my 83-degree angle. This would be my opposite side, and I have my hypotenuse. So I can use sine to find that. And I know the distance from Earth to Betelgeuse is 640. So if I look at this, that would be the sine of 83 is equal to x over 640. So 640 times the sine of 83. When I type that in, 640 times the sine of 83, I'm going to get 635. So it's a similar kind of distance. Then, since I know what's going on with this picture here, right? I know this distance now. Now I need to get this one so I can subtract it, so I can figure out what's going on up here. I have to subtract this small distance to figure out the rest of it. So I can use tangent for that. So the tangent of 83, and this is going to be times my, is equal to my opposite over my adjacent. The adjacent's the one that I don't have, so I'm going to swap those. So this is 635 over the tangent of 83, which gives me 77.96. I'm just going to call that 78. So I'm going to take my distance there. I'm coming back here. I'm going to take this distance from the North Star to Earth, and I'm going to subtract that 78. And I saw here it was 430. So I come back here. That's 430 minus 78. So I get 352. So now I have the two sides of my right triangle, and what I'm looking to do is figure out the last one. So 352 squared plus 635 squared is going to give me 527,129. So the square root of 527,129 gives me around 726. So this is going to be around 726 light years. Big, big number. Okay. So the other things that we're going to talk about today. Sine, cosine, and tangent is some common angles. This is going to be special right triangles, a unit circle. So we look at these. We have A, B, C. And we're looking at angle B in each one of these. And these have obviously just been like resized, flipped. The tangent, the sine, the cosine of that 32-degree angle, if angle B is a 32. Tangent of 32 is not going to be different for any one of these because it's a comparison between the sides, the ratio of the sides. The tangent, the cosine of the 32, the adjacent to the hypotenuse, is not going to be any different for each one of these. The sine of 32, the opposite to the hypotenuse, is not going to be different for any one of these. They're similar triangles. We have the same ratio. So what does that mean for us? When we get something like this, we have an isosceles right triangle. So we have 45 degrees. If we know that AB is 25, then AC, because these angles are the same, this is going to be an isosceles triangle. AC is also going to be 25. And that third side, we know that when you multiply this together, there's actually a shortcut to get what the answer is going to be. You're going to get a decimal, it's going to be awful, or you get something underneath the radical sign, but we've actually done one of these before when we were working Pythagorean theorem. The sine and cosine are exactly the same. It's a ratio, and that ratio is going to be, let me just type it in here. The sine of 45 is 0.7071 blah, 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 blah. The cosine of that same 45-degree angle is 0.707 whatever, whatever. It's exactly the same. And that's because we have this isosceles triangle. These sides, when you compare them to the hypotenuse, it's the exact same distance that you are comparing. So what we can actually do here is we can shortcut this whole process. If we know this is a 45, 45, 90 right triangle, then the hypotenuse here is going to be that number times the square root of 2. Well, why the square root of 2? If we look at the square root of 2, it's 0.1414 blah, 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 blah. And if we were to take 1, which is our side, and divide it by the square root of 2, we get that 0.707106 whatever. So the comparison of our side to the hypotenuse is 1 to the square root of 2. So we have a special right triangle here. If it's 45, 45, 90, whatever the side is, you can multiply it by the square root of 2. Then it says, imagine that side BC, that's my hypotenuse, is 25. Is there a shortcut to find the other sides? Well, if all we have to do is take these times the square root of 2 to get the hypotenuse, then to get the other sides, we are going to divide by the square root of 2. Okay. The next one, we have an equilateral triangle. Cool part about the equilateral triangle, it's an equiangular beam. It's an equiangular triangle. All three sides are 60 degrees. When we compare to the hypotenuse, if we chop this, we end up with a 30, 60, 90 right triangle looking like this. Well, because this is 30, it actually cut this side in half. So my hypotenuse is double what the side opposite the 30 is going to be. As compared to the hypotenuse, that longer leg, we actually have to have, because of the way things work out with the square roots, we have to have the square root of 3 in there. So this becomes x here for the side opposite the 30, and then 2x for my hypotenuse here, and then it's going to be x times the square root of 3 for this side opposite the 60. Okay, so when we have that 30, 60, 90 right triangle, if the side opposite the 30 is 5, the side opposite the 60 is 5 square root of 3, and the hypotenuse is double that 5, which is 10. If the hypotenuse is 18, the side opposite the 30 is half of that, it's going to be 9. And then the side opposite 60 is going to be 9 square root of 3. Given that the side opposite the 60 is 5, what are the other two sides? This is where it gets weird. You take 5, you divide it by the square root of 3, which ends up being 5 square root of 3 over 3. We double that to make our hypotenuse, which is 10 square root of 3 over 3. There's a weird persnickety little thing where you're not supposed to leave square roots on the bottom when you divide by them. I can talk more about it when I come back. But for today, our assignment is going to be the special right triangles assignment that is in Delta Math. We'll go over the paper from day 2, that day 2 assignment, the 2.9C. We'll go over that when I come back. We'll go over some special right triangle stuff again, and then you'll have time to work on the review because we're still going to take our test on Thursday. If you have other questions, you can email me or just save them for when I come back, and we'll see you then.